Let's make another practice for the Jacobi iteration. How about we use the same example but swap the row? Okay. For Jacobi iteration, let's swap the row order, where before you have that's 7, 15 minus 21 for the row. Let's just swap sum of the row. So minus 2x plus y plus 5z equals to 15. 4x minus 8y plus z equals to minus 21. 4x minus y plus z equals to 7. So we just swap the first row down to this third row. So we swapped. And in theory, when you swap the row, well, you change the answer of x, y, z. No. If we swap the row, we won't change our answers. But how about using the Jacobi iterations? So let's make our new matrices. For the Jacobi matrices, for the Jacobi iteration, the first step is trying to separate the xyz, isolate the xyz from the equation 1, 2, 3, right? So x equals to 15 minus 5z minus y divided by negative 2. Y equals to negative 4x plus 21 plus z divided by 8 minus 8. The z will be equals to 7 minus 4x plus y. So you can, the second step, so this is first step, just trying to isolate the x, y, z from equation 1, 2, 3. Then the second step is trying to write the new Jacobi iteration matrices, which will follow the format, which is xk plus 1 equals to a new times xk current step plus b new. Okay, and what is our a new? The a new will be equal to x, so that is 0, 1 over 2, 5 over 2, b new equals to negative 15 divided by 2. The y, the second row will be 1 over 2, 0, minus 1 over 8. That will be negative 21 divided by 8. The third row will be minus 4, 1, 0, 7. So that is our a new and b new. And let's try to see whether this Jacobi iteration can give us the same result or not. Okay. So let's share the screen of the my lab. Stop sharing. So this is the math lab. We just swap the row so that so our true solution shouldn't be changed. It should be still the same as before. Well, but after we swap the row, our Jacobi matrices has been changed. Our B new matrices has been changed. Anything else are still the same. It's just running the Jacobi iteration loop and compare the current iteration with the previous iteration, trying to see what is the maximum error. And if the maximum error is smaller than the tolerance, we are done. If the maximum error is bigger than the tolerance, we are still running the loop. Until this iteration hits 100, we will stop. So let's run this. We should expect we still get the same answers because after swapping the row, you shouldn't change. So after we run this loop, you can see the true solution is still 2, 4, 3. It's the same. but the iteration going to 99 because we already hit the maximum iteration. And if we see the pictures, so this is the picture generated from my lab. We see that we couldn't reach the final answers. It's just couldn't converge. You can see this going to 10 to the 48. That is insane. That is not possible. That means the Jacobi iterations is not always work. Okay. Then the next step is trying to see what kind of system Jacobi iteration can work. What kind of system the Jacobi iteration is not work? Where is the stability of the Jacobi iteration? And how we can check whether we can use this method or not for our algebra equations. Okay.